Hi everyone, my name is Ledesma from Bsece 3B, and this is my presentation on ECE 23 Performance Task number 4. In this presentation, we will talk about ADPCM, which means Adaptive Differential Pulse Code Modulation. So what is ADPCM of Pulse Code Modulation? Adaptive Differential Pulse Code Modulation, or ADPCM, is a variant of Differential Pulse Code Modulation (DPCM) that varies the size of the quantization step to allow further reduction of the required data bandwidth for a given signal-to-noise ratio. The adaptation to signal statistics in ADPCM consists simply of an adaptive scale factor before quantizing the difference in the DPCM. So, ADPCM was developed for speech coding by P. Kaminsky, Nickel S. Giant, and James L. Flanagan at labs in 1973. So, ADPCM produce a lower bitrate by recording only the difference between sample and adjusting the coding scale dynamically to accommodate large and small differences. ITUT ADPCM standard J.721 now replaced by the new G726 standard. ITU, or International Telecommunications Union. For ITUT is the Telecommunications Standardization Sector. So 4G721 is an ITUT standard codec for speech codecs, uses ADPCM on a 32 kilobit per second channel that was first introduced in 1984. And 4G726 is an ITUT standard codec for speech codecs covering the transmission of voice rates of 16, 24, 32, and 40 kilobit per second, introduced in 1990. So, before the digitization process, it catches the analog signal and divides it in frequency bands QMF, or quadrature mirror filters, to get the true subbands of the signal. When the ADPCM bit stream of each subband is obtained, the results are multiplexed. The next step is storage or transmission of the data. The decoder has to perform the reverse process, that is, demultiplex and decode each subband of the bitstream and recombine them. This is a scheme of ADPCM, which audio signal input QMF goes to high band and low band, to multiplexer, through transmission, or to storage. If we refer to the coding process, in some applications as a voice coding, the subband that includes the voice is coded with more bits than the other. It is a way to reduce the file size. So, where does ADPCM used? ADPCM is used to send sound on fiber optic long distance lines, as well as to store sound along with text, images, and code, or the CD-ROM, or compact disc read-only memory. So when you compress the text, image, or music, you can it uses ADPCM technique or method. This technique is used mainly in speech compression because the method makes it possible to reduce bit flow without compromising the quality. ADPCM method can be applied in all waveforms such as high quality audio, images, and other modern data. So, its algorithm is used to map a series of 8-bit ULO or ALO PCM samples into a series of 4-bit ADPCM samples. In that way, the capacity of the line is doubled. The technique is detailed in the G736 standard. So, this is the G726 of ITUT ADPCM, which has 16, 24, 32, or 40 kilobit per second basic scheme. So G.711A or you lose 64 kilobit per second input, lag A or U to linear conversion. So it goes to adaptive quantizer on 4 to 816 and 32 levels. Then proceed to inverse quantizer on 4, 816 or 32 level. Then proceed to different signal to adaptive projector, 6 zeros, 2 poles, and reconstruct the signal and cycle to and it goes to cycle to estimate use adaptive quantizer on for each 1630 level and on its output. So it transmits 2, 3, 4, or 5 bits per sample, 16, 24, 32, or 40 kilobits. This is 2, 3, 4 is a differential. Or differential that is in this line. Difference between PCM and ADPCM. The main difference between PCM and ADPCM is that pulse code modulation is the ideal when you require a high quality audio, whereas the ADPCM is best for storing with less storage space and for long transmission. So the comparison of adaptive differential pulse code modulation to pulse code modulation. So ADPCM has a sample rate is 4 bits per sample and comparatively lower quality and longer duration, more efficient, and has low frequencies will be properly reproduced, whereas high frequencies will be produced with distortion. So in high frequencies, it will produce distortion on its output. Best for long distance transmission and storing using less space, because it is using less space because it compresses the file. So in pulse code modulation, sample rate is 8 bits per sample, while ADPCM is 4 bits only. Better quality than ADPCM, which has lower quality because it's compressed. Shorter duration, less efficient. Best for audio with quality, best for quality. So if you're looking for quality output or file, you can use pulse code modulation, but if you need space for your file, you can use ADPCM or adaptive differential pulse code modulation. So that's the end of my presentation. Thank you for watching.